Alright, you guys, how did you like the exponential growth yesterday? We're going to continue on, and actually, you're kind of spared slightly because the color copy of this was even worse. It's disgusting. So, growing mold, that's an exponential growth example. Mold can spread quickly. For example, the area covered by mold on a loaf of bread left out in warm weather grows exponentially. So, I don't know if you've noticed if you had moldy food before, like sometimes our strawberries go bad too soon before we can get to them. But usually if I get the mold out, like usually it's just on 1 or 2 strawberries, it will stop. It won't continue to grow. But if I don't, then it covers all of those strawberries, right? So students at Magnolia Middle School conducted an experiment. They set out a shallow pan containing a mixture of chicken bouillon, gelatin, and water. Each day the students recorded the area of the mold in square millimeters. The students wrote the exponential equation, so m equals 50 times 3 to the d, to model the growth of the mold in this equation. M is the area of the mold in square millimeters after D days. So what is the area of the mold at the start of the experiment? So remember how we talked about 3 to the 0 power equals 1. So initially would be 0 time, right? 0 days. So initially, if we multiplied this by 1, that first thing is our initial area of the mold. So the growth factor, so this 3 would be our growth factor. That is what we're multiplying by itself based on the number of days. So what would the area of mold be after 5 days? So m equals 50 times 3 to the 5th power. So 3 to the 5th power is like putting in 3 5 times, right? So 1, 2, 3, 4, 5. 243. Remember, you have to do the exponents before multiplication in our order of operations, right? And then I have to multiply that by 50. So after 5 days, 12,150 millimeters, was that in millimeters? Yes. Square millimeters, or millimeters squared. Right? So after 5 days, this is what the mold area would be. Now, on which day will the area of the mold reach 6,400 millimeters squared? So when is the area going to be that? So we have 50 times 3 to the d, right? So we have to divide both sides by 50. 640 divided by 5. So we have 128 equals 3. So this is saying how many 3's are being multiplied together to equal D. So here is 2, right? 3, 4, 5. So between 4 and 5. So it will cover that between 4 and 5. So an exponential equation can be written in the form y equals a to times b to x power, where a and b are constant values. So what value does b have in the mold equation? So here the value was 3, and what does that value represent? The growth factor, right? What value does a have in the mold equation? That was 50, and remember we decided that was the initial. Right? The area of mold at the start of the experiment. So we have growth factor and the starting point. Initial or starting point. Alright, it's important for you to remember those things. So make sure you're understanding and writing down this equation and understanding that B is the growth factor and A equals the starting point. Remember, X is time and Y is what comes out after that period of time. Okay? Okie dokie.